So we are starting today with 8, 7, and 8, 8. 8, 7, and 8, 8. Let me try to get this. Ooh, that's really, really, really big. Let's do it that way. Okay. With 8, 7, and 8, 8, we're talking about volume. So what we've been doing so far is area. We've been doing top minus bottom or right minus left. Now we're going to go 3D with it. And I've had this really cool thing at school that I can't get to because we're not allowed to be in school right now at all. I have a drill that I take a 2D shape and I rotate it super fast with the drill, and you see it in a 3D shape. It's really pretty cool. But maybe we'll get back and I can show it to you. But we're going to start right now with volumes with cross sections. We're going to be doing squares, rectangles, triangles, and semicircles. With these, basically, we're going to find volumes two ways. This is the first way we're going to do it. This is probably my least favorite way. I like it when we rotate about an axis better, and we'll get to that. I think that's the next section. So right here, we're going to talk about solids with known cross sections. Basically, you have two ways you can do it, and you need to write both these down. If you are taking the area perpendicular to the x-axis, everything's going to be in terms of x. So if I go ahead and let me get my tablet out here. And turn it on would help too. Okay, so if I, eventually I'll try drawing it. Okay, if it starts acting up like it did at school, I'm going to be not happy at all. And let's get rid of that. Let me try this one more time. Okay. If I have cross sections taken perpendicular to the x-axis, so this way, like say I had a shape like that. If I'm going perpendicular to the x-axis, there I am perpendicular to the x-axis, you know what perpendicular means. We're going to use this. If I am perpendicular to the y-axis, trying to get a straight line like normal, and let's say my shape is that, and I'm going to be perpendicular to the y-axis, I'm going to just stop it right here. If I'm looking at this shape right in here, all my shapes are going to be this way. So I'm going to have everything in terms of y, kind of like how we did last time. If we were going up and down, everything was in terms of x. If we were going left to right, everything is in terms of y. So what I did is I took some pictures of a project that people have done in the past just to kind of show it to you. This is kind of like if you've ever gone to Walmart or Kroger's or to a deli like Curran's or something, and you get sliced meat, like you get sliced turkey or ham, or you get sliced cheese or something like that. That I kind of call this the slice method, because really what you're doing is you're just taking slices that go from one side of the function to the other side of the function, and see how they're little and they get bigger as they go. And we're just adding all these slices up to find the volume. These are semicircles over here. Just add them all up. Up here you got squares. These are isosceles right triangles. So this is kind of what we're doing, a visual representation of what we're doing here. So there's a few shapes we need to know. We need to know the square, the rectangle, the semicircle, and some different triangles. We need to know equilateral triangle. We need to know right triangle, isosceles triangle. So we're just going to come down here and talk about formulas we need to know. For a square, your area formula is just side squared, right? Good with that one? Rectangle is just length times width, base times height, however you want to think about it. Semicircle, you got to be a little more careful with this one because everybody writes down pi r squared. But if it's a semicircle, it's going to be 1/2 pi r squared. Now, triangles where it gets a little bit dicey. For a regular one, you just got 1/2 base times height. But we also have an area, and this area is for an equilateral triangle. Anybody know what the area for an equilateral triangle is?
Isn't that just 1/2 base times height?
Nope. That's that one up there. This one just has sides in it. Just S. This is where you get on your computer real quick and you Google it. Formula for the area of an equilateral triangle.
Area equals root 3 over 4 a squared,
Yeah.
where a is the side length.
root 3 over 4. I'm just going to put s squared, side squared. Okay. So for this one, a triangle, we're doing our base and our height. For this guy right down here, if it's an equilateral triangle and all the sides are the same, I mean, you could go the long way and figure out the height and take half of this and get your base, or you can just get this formula. If you have a side that's an equilateral triangle where all the angles and the sides are the same, I can use that formula right there. So that's just some of the formulas that you need to know. All of these are real basic. This is the only one that I think that you might want to write down, make sure you get that one memorized somewhere, because it's there, uh, and you can do it the long way, but it's just, if you know this one, it's just a shortcut for you. So let's go ahead and take a look at a problem. The first problem we're going to do is a volume of a solid in which the region is bound by these.
Can you jump back real quick?
Yeah.
I need equilateral.
Okay.
Thank you.
You're welcome. Okay, so what we're going to have to do first, the very first thing you're always going to do is you're just going to graph them. So if I come over here and graph these, I got to think about what I'm graphing. I'm just graphing lines, correct? Y'all okay with that? So if I come over here, so this first one, I'm going to rewrite it up here. It's going to be blue. It's going to be negative 1/2 x plus 1. That puts it more in the y equals mx plus b form, so it makes it easier for me. So I know I'm going to be up here. I'm going to go down 1 and over 2, down 1 and over 2, up 1 and back 2. And my dots will be blue, but my line's going to be black. So it's going to be a better looking line. Okay. Then g of x, I'm going to rewrite it like what now? Somebody say something to me. It's going to be 1/2.
James asked a question a minute ago, but I didn't hear him.
Oh, what'd you ask, James?
Sorry, I was just wondering, is this online? Is this slideshow online anywhere where I can follow along?
Well, I mean, it's on you can see it, can't you?
Yeah, I can see it. I was just wondering.
I mean, I can start putting it on Google Classroom if you want me to. I'll do that today. Okay. Okay, this guy right here. Did you have another question, or was that your only question?
That was it.
Okay. So I'll be down here at negative 1. I'm going to go up 1 over 2, up 1 over 2. Make sure I graph these right. And I've got that one. And then I've got x equals 0. Well, x equals 0, make sure I'm right for this one, is this line right here. Do you all agree with me? So we're looking at this area inside of here. This triangle in here, we're looking at that. And you do that before you worry about what kind of shape you're looking at. Now, what we're going to do is now, once we have that graphed, we are going to put squares. We're going to put squares in there, and they're going to be perpendicular to the x-axis. So we're going to have squares going like this, and they're coming out of the computer screen. And if you notice, so it's kind of like, I'm not going to be able to draw a 3D, but it's kind of like squares like that coming out of the computer screen at you. And if you'll notice, the sides, of course, squares are all the same. The side of my square is just the blue line minus the red line. Can you all see that? Any questions on how I came up with that? Okay, if there's not, what we're going to do now, I'm going to jump back here for a minute. We're going to use this guy right here. We're going to find the volume from A to B of the area. So if I come back down here to my problem, my A, I'm starting at 0. My B, they're crossing at 2. And now, what I'm going to have to do, I'm going to go ahead and work this out to find my side. I'm going to distribute. And I'm going to end up with a negative x plus 2. Did I do that right? Y'all agree with me? Y'all know I'm not good at math. Okay. So now our shape is a side. And we know the area of our shape is a side. Our shape is a square. And we know the area of a square is side squared. So I'm going to come in here and I'm going to say negative x plus 2 quantity squared dx. And this is what I'm going to antiderive. Now, I can't antiderive this the way it is right here. I mean, technically I could, but I'm going to go ahead and change it just so it looks more comfortable for you all, some of you all probably. I am going to make it, this is like negative x plus 2 times negative x plus 2, x squared minus 4x plus 4 dx. So I just FOILed it out, so it's going to be easier to antiderive now. If I antiderive this, I get 1/3 x cubed minus 2x squared plus 4x. Now always take a minute, take the derivative, make sure I got what's above it. So I got x squared minus 4x plus 4. And I'm going to go from 0 to 2. So I'm going to have 1/3 times 8 minus 2 times 4 plus 4 times 2. Now, I know I can sub the 0 in, but if I sub the 0 in, I'm just going to get 0 back out. So if I'm doing this like an FRQ, I would come in here and go ahead and put a minus 0 right there just to show that I recognized it. Okay? If it were a multiple choice, I wouldn't even bother with that. So now I got 8/3 minus 8 plus 8. So my answer to this problem is 8/3. And that means the volume of all these squares added up, if I stacked them all up, would be 8/3 whatever units squared. So ask me some questions on that. Nothing?
So when you're finding your side, is it just the top one minus the like bottom one?
Yeah, yes. Yeah, it just kind of depends on what it is you're doing. Like the next one, we're going to be using the same shape, but instead of squares, we're going to be using semicircles. So the top minus the bottom for that's going to be your diameter. So you just got to know what shape you're putting in there to know how you're going to use it in your equation. Other questions for me?
So when you're looking at the shape, it's what the big shape is being cut into.
Yes, exactly right. Yes.
Okay.
Yeah.
Okay, thank you.
Kind of like back here. Like this one, it looks almost just like that. And because like at the vertices of the triangles, they get smaller, and then at the base of the triangle, it's bigger. That's almost exactly what it would look like.
Okay, thank you.
You're welcome. So a lot of times what I'll do with these problems is many times you're going to be asked to use more than one known shape. So when you're doing that, the very first thing I do without even looking at what I'm going to do down here is I go ahead and I graph it. And then like this next one I'm coming to, the cross-sectional areas, again, perpendicular to the x-axis, so we know they're all going to be x stuff, or semicircles. So the area of a semicircle is 1/2 pi r squared, right? We're still going, our bounds aren't changing. We're still going from 0 to 2. But this time in here, instead of squares, we're going to come in here and we are going to have semicircles. So we're going to have something like, there's my diameter, and we're going to have like circles coming out. So like the dome part is coming out of the screen at you. Those aren't very good semicircles. That's all I got. So what I need to know now is my diameter of my semicircles is top, and my top was the blue one, minus bottom. And if I look at my formula over here, I don't want that. All I want is the radius. So to get my radius, I'm going to have to come over here. And if you'll notice right here, isn't right here top minus bottom f of x? And it was minus g of x right here. And this is the same thing. So I don't like have to totally redo this again. I already have this. I'm just going to make it minus x plus 2 over 2. And now when I come over here to put in my formula, I'm going to write it down right here, but right quick, I'm going to get rid of these. I've got that. I've got negative x plus 2 over 2 squared dx. And this is just my 1/2, my pi, and my radius squared. So take a minute and look at that. I got scared real quick. I hadn't videoed it, but I did. Whoosh. Okay, no questions?
Is it always going to be f of x minus g of x?
Well, it just kind of depends on what. It's always top minus bottom for this. If there's a top and a bottom like we have right here, and it just happens that f of x is the top, g of x is the bottom. It seems like it is a lot, but as soon as I say that, those will flip flop names. So in my head, when I'm doing it, I'm saying top minus bottom, and just for this problem, it's always going to be. But other problems, f and g might switch places. Does that make sense?
Yeah, thank you.
You're welcome. Okay, so we've got some constants in here. We've got this, and we've got this guy right here. But this guy gets squared. So this is really a 4 under here. So I'm going to do my integral symbol 1 to 2. I'm going to take to the outside 1/8 pi. So take a minute and think about why I could do that. And then I'm left with this on the inside. Well, this is the same as that, right? So I can come in here and say negative x plus 2 squared dx. And if you'll notice, this is the same exact thing as this. And the answer we got for this one was 8/3. So I'm not going to reinvent the wheel. I've already done this in A. So I've got my 1/8 and my pi. And I found up here in part A that this answer was 8/3. So then I multiply everything together and I end up with pi over 3. That's my volume if I were to use semicircles in there and add up all the semicircles. Now you can work it out again. It doesn't always work out that pretty, but most of the time, if you start with a square, you can use that stuff again.
I'm a little confused on how we went from 1/2 pi to 1/8 pi.
Okay, so I put a green circle around the 1/2 pi, and I put a green circle around the 2. The 2 is squared. This whole piece in here is getting squared, and I could just basically separate it, and I have this squared, which is right here, and then 2 squared. 2 squared is 4. So I was able to take this and the 1/4 to the outside, and I multiplied the 1/2 and the 1/4 together. Basically, this is like
When I'm multiplying 1/2 times 4, I'm getting 2.
the 4 is on the bottom. It's like this is the same thing as 1/4.
Anthony, you're multiplying 1/2 by 1/4. It's not multiplying it by 2. You're multiplying it by 1.
See, it's sitting out here now, so I'm going to multiply this by this in the green circle, and that's where the 1/8 comes from. You can't just magically pop the 4 to the top. Okay, it has to stay in the denominator. You're welcome. Other questions for me? Now, these are not questions you're going to get done super fast at first, especially. You're going to kind of get into a rhythm of them, but they can be, this first time you're seeing them, they can be a little confusing. So if there's no questions on A or B, I'm going to show you another cross section. Okay, hearing none, I'm going to talk about this one. Okay, we're still perpendicular to the x-axis, so we're still going up and down. I'm going to erase my semicircles now. Now we have rectangles. So my rectangles are going this way, and their heights, no matter what, for these rectangles coming out, these heights are 3. So I got a bunch of rectangles in here coming out whose height is 3. So their width is changing, but their height is not. So if I'm thinking about that, my area for this is going to be 3 times the width. Length times height, length times width, however you think about it. And my W, again, I'm going from top minus bottom, is f of x minus g of x. My bounds are not changing. So I'm going to say the integral from 0 to 2. Now to find the area of this, it's 3 times f of x minus g of x. And back up here, we had f of x minus g of x. Remember oops, gosh, this thing keeps moving on me. Right here. So I've got f of x minus g of x is negative x plus 2. So I'm going to come down here and I'm going to multiply this by negative x plus 2 dx. Now you have an option here. I prefer to go ahead and put the 3 on the outside because the less I have to mess with, the better. And I'm just going to be taking the antiderivative of that. So I'm going to have 3 negative 1/2 x squared plus 2x. And notice I didn't have to square it or anything because the area of a rectangle is just base times height. And I'm going from 0 to 2. So I've got my 3. And I've got my negative 1/2 times 2 squared plus 2 times 2. And that gives me negative 2 plus 4 is 2. That gives me 6. So if I use cross sections that are rectangles with a height of 3, I'm going to have 6. Questions on that one? Ooh,
So width,
what now?
width in this case is from top to bottom and not left to right on the triangles.
Say that one more time.
Width is like in this case is from top to bottom.
Yeah,
Not
right.
like left to right.
Yeah.
Okay.
Okay, who's all that noise? I want to come over here and find out. Anthony, is that you? Okay, y'all shh. Okay. So what you have to know, it has to tell you what it's going. Like if it was going this way, then it'd be something totally different. We couldn't do this problem going this way. So they have to tell you which way they're doing it. So that was with rectangles in there. And what you'll notice if I look at these, like this rectangle, the base of it is much smaller than this rectangle. And the base of the farthest out rectangle is 2. So they change as they go. They get a lot smaller as they get towards the tip, and they keep getting bigger and bigger and bigger as they get towards what I call the base. Now we have one more to do. This one is the equilateral triangle one. So with the equilateral triangle one, shoot. I'm trying to pull it down a little bit. Y'all know an equilateral triangle, all the sides are the same and all the angles are the same. So if we're looking at our graph up here, I'm going to get rid of these rectangles this time, and we're going to have triangles coming out. The pointy end of the triangles coming out at us. So here is our side, and then we're going to have triangles. I don't know if I'm able to draw these or not, coming out of the screen this way. So like that point is coming out at you. And all of these triangles are going to get filled up in here. And if you'll notice, the side is again f of x minus g of x. So because we have the formula area equals 4 square root of 3s squared, is that right? Is that what we wrote down a minute ago?
Yeah, you need to flip your 4 and your root.
Yeah.
Yeah, you have to be careful with that because that, I actually did do that one on purpose this time because that is what people do all the time. Okay, in my mind, I'm thinking I'm taking 3/4 of a triangle, and that's stupid, but it keeps me straight. I don't know why. So again, we know our side is f of x minus g of x because, again, all of these sides on this triangle are all the same length. So f of x minus g of x is negative x plus 2. And again, where our bounds are still 0 to 2. I'm going to take the radical 3/4 and put it on the outside. It's a constant. The integral is not going to change it. And I'm going to have negative x plus 2 quantity squared dx. And you're going to find a lot of times on these, that's all the farther they want you to go. They don't actually want you to work it out. They'll just say, okay, develop an integral, develop an antiderivative that will help you find the volume of the cross section. But ours did not. But we already have this answer up top. We already did this way back in part A. So if I go back up here to part A, we got 8/3. I'm going to come right here and multiply this by 8/3. And I'm going to get 2 square root of 3 over 3. And that's going to be the volume for that one. So there was what? How many problems did I just do just then? Let's look at all of it all together.
A lot.
Well, thank you, Josh. I got 1, 2, 3, 4. That's not even a whole hand's worth of fingers. Come on. But you're going to want to take some time and kind of step through and look at it again. If you have to do more than one on the same thing, again, you can steal stuff from the other pieces a whole lot. If you'll notice, I use this here. I use this down here. And I could have just totally redone it again, but I don't have to. So I just wanted to show you that one.
On
Question.
an FRQ, would they just recognize that you were going back and using the same stuff?
What I would do probably this right here, I would go ahead and f of x minus g of x. I would take this, equaling it to here, and I would somehow refer back to it. I would make sure that, and honestly, you're not going to have to do all of these on FRQ. You might have to do 2. So it's not like there's so much other stuff they can torture you with. They're not going to spend a whole FRQ just on this. Maybe 2
What you
pieces
could
of it.
probably do is set a symbol equal to that, like a variable they don't give you, like b equals that, and
Yes,
refer
that's
back to it.
yeah, like this right here. B equals this, and then notice I wrote it down here, and then I could just say, okay, put B in that spot, and then I put the 8/3 there. Does that make sense?
Yes, thank you.
Okay, if it doesn't, make sure you say so. Okay. Okay, we're gonna look at another example. If there's no more questions about this example. I've got one more example to look at. Now we're going to talk about a circular base. Okay, so let me get it wider so I can write on it. Okay, we have to find the volume of the solid in which the base is a circle of radius 3 units whose cross sections are described. Okay, so let's talk about what we have here. Find the volume of the solid in which the base is a circle of radius 3 units. So how would I graph that? Any thoughts?
Isn't it just a circle of radius 3 around the origin?
So you're saying I'm going to come here, I'm going to come here, I'm going to come here, and I'm going to come there, and I'm going to make a circle at those points. Does that make sense to you guys? Because what we're going to have to do... Go ahead.
I was agreeing. Sorry.
Okay, you're fine. What we're going to have to do, let me go ahead. I'm way not going to try to draw this circle. Oh, and I'm way not going to be able to draw it. Hold on. Okay, I'm going to do that, and then I'm going to do this. Ta-da! Okay, there's my circle. Now, y'all know, do y'all know the equation for a circle? You need to know that. They're going to expect you to know that.
For the area?
No, just the equation of the circle.
X squared plus y squared equals your radius squared.
Yeah, y'all okay with that? Now, here's the deal. Our A right here says a cross section is perpendicular to the x-axis again. So we're going to be going this way again. Our squares. So we're going to be having squares coming out of the screen towards us with all these different side lengths. All of these are squares coming out at you. So it's kind of like pretend like that's a square. That doesn't look like a square at all. Pretend. You're going to have squares come at you that way. But here's my deal. To get my side right here, don't I need top minus bottom again? So I'm going to have to come up here to this. I'm going to have to say y squared equals 9 minus x squared. Y equals the square root of 9 minus x squared. And I had a really good calculus teacher that told me that I had to put a plus or minus there. So basically what I have, I'm going to make the top blue. The top equation is positive 9 minus x squared. The bottom equation is negative 9 minus x squared. You have to break them up into their two pieces because what's happening is this top hemisphere is that's the equation for that one. And then my bottom is that one. So when you're trying to find the side length, you're going to actually have to subtract these from each other. So if I'm going to come over here and I'm going to look at it, I'm going to be going from -3 to 3. Yes? You good with that? Now, I know it's a circle, and right here people are dying to do something with power squared, but I am done with the circle. I don't care about the circle except for my top and bottom part. What I'm going to put in here is I'm going to say, let's do it off to the side. Let's come over here and say side equals top minus bottom. And I end up with 2 square root of 9 minus x squared. So that's my side. So I'm going to come down here and say 2 square root of 9 minus x squared dx. Because remember, the area for a square is side squared. So now, I'm going to pause for a minute. Are y'all okay with what I just wrote down? Or you have questions about it? Okay, if not, I'm going to take, and I'm going to go from -3 to 3. I'm going to square everything in here. If I square everything in here, I'm going to put the 4 on the outside. 2 squared is 4. The square and the square root undo each other. And I now have 9x minus 1/3 x cubed. And I am going from -3 to 3. Okay. Now I'm going to finish this out because we have 2 numbers here, make it a little more challenging. I'm going to put the 3 in. I'm going to get 27 minus 3 cubed is 27. 27 divided by 3 is 9. Minus, now I'm going to put in the -3, negative 27. Plus, if I put a -3 in right here, I get a negative 27 divided by a -3 is a positive 9. And that 4 is just sitting out there till I get done. So I'm going to distribute, plus, make that a minus. So I end up with what? 27 minus 9 is 18. 27 minus 9 is 18. Did I do that right? Y'all agree with me with my math? Nobody's fussing at me yet. So I end up with 36 times 4, 144. So it's just basically like just what we were just doing. Just our top and our bottom are different. Any questions? Okay, what I'm going to do for the rest of these, I'm going to set the integral up, but I'm not going to finish it out just because this is kind of getting drawn out. And I just want you to see what you would have to take the integral of, because that's the new stuff right here. Taking integrals isn't the new part. So if we're doing semicircles, area equals 1/2 pi r squared. We're going to go from -3 to 3. I'm going to put the 1/2 pi out front. Now again, we know top minus bottom. We found it up here. It's 2 times the square root of that. So I'm going to say, oops. I forgot it. How bad is that? 2 square root of 9 minus x squared. And this is where people always get it wrong. Because you have to remember, you have to divide that by 2 because that is your diameter. If I'm going from here to here and I have circles coming out of it, then my radius is half of that. So I'm going to end up taking the integral from -3 to 3, again, of 9 minus x squared dx. And that should look real familiar to you from somewhere up higher. So that would be semicircles. Our equilateral triangles are
Was your pi over 2 turned into pi over 8 from where you pulled out the...
You're not going to take it out this time, because what you're going to do right here is those are going to cancel each other out,
Oh, okay.
and then you square it. Good question. My area is square root of 3 over 4, side squared. Again, going from -3 to 4, the square root of 3 over 4 out there. We know our side squared is 2, 9 minus x squared, squared. And I'm going to let you all finish that one out. Okay? Not right now. I'm just setting them up for you. Now, if you have questions about going farther than that, you need to be asking me. But I figure right here, I would...
Why is your integral from -3 to 4?
Because I'm stupid. Making sure you're paying attention. I just want somebody to talk back to me. So sad and lonely. Okay, thank you. Okay, now, check out this one. This one's different. This is an isosceles right triangle. If it's an isosceles right triangle, those two sides are going to be the same. That makes it a right triangle. The cross section is perpendicular to the x-axis. Our isosceles right triangle. Ooh, catch this. Whose hypotenuse resides along the base. So this is kind of crappy looking. It doesn't even really look like that. It looks more like it got dumped over on its side. So if we come up here and we look at our circle, what we're going to have in this circle now is the base is right here, those triangles, and the sides that are coming up at a point, these sides that are coming up at a point are equal to each other, and we have the right triangle there. So here's my problem. From here to here is my hypotenuse. So I'm going to come down here. Wow, I don't know what I just did. I think I moved that. And I'm going to say my hypotenuse equals top minus bottom. And that's 2.
You pulled E up instead of pulling D up.
Oh, okay. Thank you. E is a lot easier than D. I got 9 minus x squared. So that's my hypotenuse right there. Okay? So if this is my hypotenuse, which is my side, how am I going to figure this out? What can I do?
If it's an equilateral, isn't there a formula? I think it's...
I don't know a formula.
Could you use something like Pythagorean's theorem for this?
That's what I'm thinking. Can I call both these sides P for Pam? If I call both these sides P for Pam, now I'm going to say h squared equals 2p squared. You all good with that? H squared equals p squared plus p squared. And then if I come in here and I replace that, I'm going to have 4 times 9 minus x squared. I went ahead and I squared all that. Equals 2p squared. Divide both sides by 2. So my sides of there end up being the square root of 9 minus x squared. Isn't that? I guess it's that kind of makes sense actually. Okay. But what do I do now? I got my hypotenuse and I got my sides. How do I find the area of this triangle? How do you find the area of a triangle?
Do you want to have base times height?
Yeah, you want to have base times height. Because now we have our base and our height. So I'm going to come over here. I'm going to go from -3 to 3.
Wait, do you need to do plus or minus on the square root?
Do I need to do plus or minus on the square? No, because this right here, my h that's in red, it came from where we already did that up here already.
Okay.
Okay. So that was just we were able to use from something previous. So I'm going to put the 1/2 out front. Now, what's nice about an isosceles triangle, my height and my base, they're the same, right? So I can just come in here and say base times height. And won't you know, if you look at it, we kind of end up back, just like that show Lost. You always end up back where you started.
That show made me really mad.
We kind of end up back where we have been before. That's a really easy integral to take. But this is a tough one. You're going to have to go back and look at this. Because I have
Where
to.
did the extra 2 go? Because there's another 2 in the a squared equals 2b.
Right here?
Yeah.
I had 2 over here.
Yeah, you had a 4.
Oh,
there, right?
okay. So let me think. What did I do with it? I lost it. So I should have.
Whenever you took the square root, I think you just dropped the 2.
I think I did too. So can I come in here and put the 2 in right here? Let's just start this over again. So right here, I have 2 times 9 minus x squared equals p squared. I'm going to go ahead and make this 18 minus 2x squared. You okay with that? Because then when I go to do this to it. Oh, I see what you're talking about the plus and minus. That's what you're talking about, right, Ben? Benjamin? I know he was just talking. Yeah, talking about the plus or minus here.
Yeah.
Okay.
Yeah, that's what I was talking about.
Okay, thank you. Because this is a measurement, we're taking this measurement, we're just taking the positive of it.
All right, thank you.
Okay. Well, thank you. So let me come over here and fix this. So over here, we're just going to have 18 minus 2x squared dx. And I need to fix it up here also. 18 minus 2x squared. Okay. Now, D is the hardest one. E is going to be easy after D. You don't see D a whole lot, but it's on there enough that you really got to make sure that you kind of get what I just did just then. And it may take you some time looking at it later. You may need to do a Khan Academy video on it to hear how somebody else does it. But that's like I said, that's probably the most in-depth one because E is this thing right here. It's still an isosceles right triangle, but instead of the hypotenuse being there, you got your leg being there. You got this guy up here. Let's see if I can grab it. Where this goes from side to side. So this is my side right here, and we know our side is 2 9 minus x squared. So this is super easy. -3 to 3, my 1/2. This is my base. This is my height. And that's what you would take the antiderivative of. You know, you'd work it out. But see how much easier E is? This is just area 1/2 base times height, 1/2 side times side. Okay. Now, here's my plan for Monday. You're going to have a quiz, but all I plan on doing on Monday is answering questions on this. So you better have questions on this. Okay, I really don't want to move on, but if you don't, I'll be ready to if I have to. But I'm really thinking that this homework is going to be some stuff that you're going to really need to take a look at. What I have down here is just kind of like a cheat sheet where it talks about all the different types of things you can do. The isosceles right triangle with hypotenuse in the base. The isosceles right triangle with a leg in the base, equilateral, semicircle, rectangle, square. It's got all of them on here. And this is kind of the cheat sheet you need to look at when you're trying the homework. Okay. So I'm done. If you have homework questions, you can hang out in here. I will say, let's do this real quick. Go over here and look at this. Like I said, help, I actually had this assignment in there. Oh, there it is. if you see anything weird, like stuff like not showing up, make sure you say something to me about it, because things have been dropping. I'm not real sure why. But this is just like what we did just now. You've got 2 of those. You got one that you can use a calculator on. So there's 6 of them. Of course, when I say there's 6, there's more than 6. But any questions for me?
Can you do one that's where it's perpendicular to the y-axis just to see it?
Let's do that Monday. Let's just not. I think we've kind of. I feel like your brains are probably a little bit on overload with just the X stuff. So, people leave me so fast. I'm so sad. It's like you're walking out of my room while I'm still talking.
Only 3 people left, Mr. Shea.
But I heard it, and it hurts. Anyway, right here. Check this out. If you need a calculator, it's down there. If you have questions, be sure to ask me. Again, 8-4 to 8-6 quiz on Monday. So that's it. And I will talk to you guys on Monday. Bye.
Bye, Mr. Shea.
Bye.
Bye,
So,
Mr.
bye.
Shea.
Come on, I need some more buys. Bye. Bye.
Happy Friday.
Bye.
Bye,
Oh,
Mr. Shea.
they're
Have a great
all-
weekend, Mr. Shea.
You too, Ben. You're all leaving me.
Hey, Mr. Shea,
Yeah.
you want me to explain that thing I was talking about last night?
Not yet, because I got to finish getting ready for your little physics test. So we'll talk about it a little bit, okay?
All right.
Okay.
See you, Mr. Shea.
Okay, bye, y'all.
Bye bye.